Good afternoon, advanced algebra students. I am super excited to be working with you again. I feel like it's been ages since I've seen you, and actually it really has been. So we finished, I don't know if you even remember this, but we finished up through chapter 2 in our advanced algebra book at the end of quarter 2. And in quarter 4, we're going to do chapters 3, 4, 5, and 6. So we've got a lot of the Algebra 2 book to work on this quarter. We are going to start off with lesson 3.1, graphing polynomial functions. And basically what we're going to talk about is some parameters to consider when we are graphing functions of sometimes higher than power 2. So it could be power 3 or higher. We spent a lot of the second quarter learning to graph quadratic functions. And so we learned to graph them in vertex form, standard form, and factored form. We also learned how to solve them. But in chapter 3, we're going to be talking about working with higher degree polynomial functions. So the first thing that we might want to talk about is how to classify polynomials. So classify polynomials. So let's give an example of a polynomial. So for example 1, let's say our polynomial is f of x equals negative 4x plus 9 plus 2x cubed. Okay, so this is called a third degree function. We're going to talk about what standard form is for this. So standard form for a polynomial function means that you go from the highest exponent down to the lowest. You combine any like terms. So there are no like terms to combine here, but the highest power is x cubed, so that should be our first term. So we're going to write 2x cubed first, and then x to the power of 1. There's an invisible 1 on the top of that x there. That would be our next power. So that term would come next. We would write minus 4x. And you can think of the 9 as being 9 times x to the power of 0 if you want, but 9 would come last. So that would be in standard form. The degree, as I mentioned a second ago, is 3, and that is because our highest exponent is power of 3. Now, we also talk about something called terms. A term is a monomial. A monomial is numbers and letters multiplied together. So for example, 2x cubed is a number 2 and the letter to a power x cubed. That would be a monomial. Monomials are separated by plus or minus signs. So this has 1, 2, 3 terms because we have 3 essentially pieces separated by pluses or minus signs. And then the last kind of vocabulary word here is leading coefficient. Leading coefficient is a term we'll use a fair amount. The leading coefficient is the number in front of the x to the highest power. So in this example, it would be the number 2. So classifying polynomials is really important. Another thing that we need to talk about is end behavior. End behavior. Now, it is exactly what it sounds like. It is how the ends of a function behave. So it describes what happens to the function values as x approaches positive and negative infinity. Now, whether or not the function is odd or even will make a difference. So if we have a polynomial function of odd degree, this is really easy to remember, then the ends go in opposite directions. If the polynomial is even degree, what do you think happens then? If the polynomial is even degree, so for example, an x squared, like a quadratic function, or an x to the power of 4. If it is even degree, the ends will go the same direction, just like in a parabola. So the ends go the same direction. So it is important anytime we're looking at a polynomial and want to kind of understand the basics of graphing it, to ask ourselves, is this an odd degree function or an even degree function. Then we also want to look at the leading coefficient. If we have a positive leading coefficient, that means that the right-hand side, and I'm abbreviating that RHS, goes up. What do you think happens if there is a negative leading coefficient? If there is a negative leading coefficient, the right-hand side goes down. So let's go ahead and look at a few examples. And so we'll do, I don't know, maybe let's say 2 examples. So we'll do example 2 here. Example 2 is f of x is equal to x plus 2. So I'd like to see if you can write what is the degree and what is the leading coefficient. What is the degree and what is the leading coefficient? The degree is going to be 1 because of the power of 1 right here, which is an odd number. The leading coefficient is also 1, which is positive. So because it's odd, we know the ends are going to go in opposite directions. And because the leading coefficient is positive, the right-hand side is going to go up. This is going to end up being a line where the right-hand side goes up, and because the ends go in opposite directions, the left-hand side is going to go down. Okay, let's look at another example here. F of x equals negative x squared plus 4x minus 3. Again, we want to make a note, what is the degree and what is the leading coefficient? So go ahead and do that. While you do that, I'm going to erase some of the material that we had over here. All right, the degree should be 2 because of this number right here, and the leading coefficient is negative 1. The degree here is even. That means the ends are going to go the same direction, and since the leading coefficient is negative, the right-hand side is going to go down. This is going to end up being a parabola where the ends go the same direction and the right-hand side and the left-hand side, because they're going the same way, are both going down. Let's do one other example similar to this, example number 4. Let's go ahead and look at g of x is equal to negative 5x cubed plus 8x plus 4. Again, we want to make a note of the degree and the leading coefficient. The degree is 3. The leading coefficient is negative 5. 3 is odd, so the ends go the opposite direction. The leading coefficient is negative, so my right-hand side goes down. Now, one way that we can describe this mathematically, instead of saying right-hand side, we can say as x approaches infinity. That means as x is going to the right, then we say that y approaches negative infinity. So that is a fancy way of saying that the right-hand side goes down. So as we move to the right, as x approaches positive infinity, y goes down or approaches negative infinity. Now, let's talk about what happens as x approaches negative infinity. That means as we go to the left. Because the ends are going in opposite directions, as we go to the left, y is going to approach positive infinity. So oftentimes in this textbook, instead of saying right-hand side and left-hand side, they're gonna say as x approaches infinity for going to the right, y is going down, or y approaches negative infinity. And then here the opposite direction, as x goes to the left or towards negative infinity, y is gonna go up because the ends are going in opposite direction. Now, your graphing calculators are going to be helpful to you, very helpful in terms of graphing. In this particular version of the class, I do not believe we are going to have any tests without a calculator. The flip side of that is you are kind of expected to be able to graph anything on your calculator. So I will help you with this a little bit more when class gets started. But we can tell by looking at our graphing calculators where the zeros are and where the turning points are as well. So let's do another example. I believe this would be example number 5. And let's go ahead and graph f of x is equal to negative x cubed minus x squared plus 9x plus 9. And then we're going to go ahead and draw our xy axis here. And in the homework, as well as on quizzes or tests for this chapter, you're expected to be able to come up with the zeros. Now, I believe that we talked about this last quarter, but 0 is a fancy name of saying what is x when y is 0, or what is the solution to this problem. And then turning points means where does the graph change directions? So we'll talk about that in a minute. Turning points is another helpful tool. We want to know what are the turning points. So I'll write this down and we'll fill it in just a minute. And we also want to know the end behavior. So in order to graph this on your graphing calculator, you are going to want to find the y equals button on your calculator. Now, most of you should have a TI 83 or 84, and you could look here and see that there is a little y equals button right there on your calculator. So you push the y equals button, and then you do want to clear out anything that was there before. Now, to write negative x, you do need to use the negative button right here, not the subtraction symbol over here, but the negative button right there. So you're going to go negative, and then for the x, you're going to use this key right here, the one that says x on it. So negative x, and then to do to the power of 3, you use that caret button right there. So negative x to the power of 3 minus x to the power of 2 plus 9x plus 9. After you enter that, then you want to hit the graph button, which is right there. So we hit the graph button. Now, when you do that, it is going to show you a picture of your graph. Notice that this graph crosses the x-axis in 3 spots, here, here, and here. I can see on my graph that those points are -3, -1, and +3. So I'm going to put a dot at -3, at -1, and at +3. I also want to know where the turning points are. So I can see just by kind of sketching this graph here that between -3 and -1, the graph changes directions here. So that is a turning point. Let me put a little label here, turning point. I can also see that between -1 and +3, between these two numbers, I have another turning point. Again, the graph changes directions there as well. Now, if I want to describe the end behavior, The end behavior is that as x approaches infinity, so let's just write this right here. As x approaches positive infinity, that means as we go to the right, y approaches negative infinity. That is a really fancy way of saying that the right-hand side goes down. We also want to make a note of the fact that as x approaches negative infinity, that means as we go to the left, y approaches positive infinity. That means that the y values go up. Now, one thing that you might notice is that this is a third degree function, and we had 3 zeros. That is typically the case. Now, you don't always have exactly 3, but you can have at most 3. So for example, a third degree polynomial function can have no zeros, 1 zeros, 2 zeros, or 3 zeros. It will typically have 3, but it will have at most 3 and usually 3. Okay, so we're going to talk about one more example here. This is going to be example number 6. And that is how you can sketch a graph from a verbal description. So to do a sketch from a verbal description, there's a few kind of tips that we can follow. The first is to identify or estimate or plot the x-intercepts. Those are considered to be key parts of the graph, and so if you can get those, plot those. Then the next step would be to indicate the turning points. And then the last step would be to evaluate the end behavior. So this kind of follows what we've been talking about on the graphs so far during this lesson. So this example is kind of complicated. I don't know, I do think we may have one test question like this. I'll have to double check and see, but there's not going to be a ton of them. In this example here, we're going to say that f of x is positive on the intervals from negative infinity to -4 and from -1 to +4. And we're also going to make a note here, this is all information that's given to you, that f of x is negative on the intervals from -4 to -1 and from 4 to infinity. So let's think about what that means. Let's see, we can also talk about when they're increasing or decreasing, but we kind of know from the descriptions that we've been given that something is important is happening at, let's put here 0, at -1, at -4, and at +4. Because we're being told that x is positive from -4 to infinity. F of x is positive. So that is essentially telling me that the left-hand side there is going up. I'm also being told that f of x is positive between -1 and 4. So for right now, I can just kind of draw a curve like that. Again, I know that the y values are positive in those two spots. Now, where is f of x, of course, is another name for y. Where is y negative? It's negative between -4 and -1, so there. And also from 4 to infinity, so there. Now, in this particular case, we're also given a little bit more information. We're given that f of x is decreasing. That means going downhill from -infinity to -2.67. and from 2 to infinity. So I can fine tune my graph a little bit. It's telling me here that at 2, let's see, oops, that's not 2, that's 1. At 2, the graph starts going down. So I can, if I want, kind of fine tune this a little bit. So that at 2 is where the graph starts going downhill. And then I know that the graph is also going downhill all the way up into negative 2.7. So that would be about right there. And that is pretty accurate to what I already had. And we are also given the fact that f of x is increasing on the interval from negative 2.67 to 2, which is what I have here. It's increasing all of this spot right there, all of that interval right there. So the question is kind of asking here at the end of, what I would normally be talking with through you as we do notes, that how do the key features of a polynomial function help you to sketch its graph? Knowing whether the function, the degree is odd or even is helpful. Knowing the leading coefficient can also be helpful. And evaluating the end behavior, turning points, and x-intercepts all can help you to sketch a graph. So this section of the book is really about giving you tips for sketching graphs of functions that are higher than degree 2. Thanks so much, you guys. I can't wait to see you in class. Bye.